Aloha and welcome to the final day of PTC'21, New Realities. My name is Grace Lowe and I'm with PTC. We hope you've enjoyed the conference so far and all its offerings. Let's get right into today's session, Strategies to Meet Network Needs, with moderator Phill Lawson-Shanks of Align. Phill?
Thank you, Grace. And let me just share my screen with you all. So we'll start the presentation. There we go. And put that into presentation mode. There we are. Okay. Well, thank you. And thank you for taking this, this hour out of your day. Obviously, we'd all like to be there with you. And one of the things we'll be discussing here are some of the reasons that we can't be, obviously, and the things that the industry has taken upon itself to address those needs. Obviously, we've seen a tremendous shift in the whole of our technology. That the pandemic has had a really interesting effect. Interesting, maybe that's the wrong term, but on how we work and play and communicate with one another. We've really seen digital transformation come forward probably about 10 years ahead of the predicted cycle, and that has obviously put a tremendous strain on the core infrastructure. So what we're going to talk about here are some of those strategies, those fundamental pillars that that keep all of our digital lives, both in business, commercial, and in domestic, up and running. We've got some wonderful speakers here that are joining me on this panel. Let me just advance the slide. There we go. Dan Davis, the CEO of Arcadian Infracom, he's going to talk about a lot of those realities and how the work that Arcadia Infracom are doing to connect new portions of the globe. Then we have Edmond, I beg your pardon, Ben, from Connected to Fiber. He's going to talk about some of those the challenges in finding those connected points and the tools that we need to bring those to the bear. Then Jeff Brown from Calix will be talking about the transitions of communications using 5G and other methodologies and how that's shaping our world. And then Doug Madory from Calix, he's going to talk about some of those network operations that are fundamental to keeping all of these systems operational and running. And if there's time at the end, we'll do a wrap up and a Q&A. Grace will be keeping tabs of your questions. Please put them into the chat. And if you would address the speaker that you want to address those questions at the end, we'll be able to take that as we go through. So let me set the stage here and talk about speed being the new scale. So COVID-19, obviously it's changed the whole world here. We've seen a shift to everything being moved to the online world, and the hyperscaler services to accommodate those have just ramped beyond all portion. I think as we get to the end of Q1, we'll see more of those reports coming out as people are putting their Q4 numbers to bed. We'll see an even more dramatic shift. But you see on the slides on the right here, some of the market that shifted towards the hyperscalers. Tremendous growth just last year in that, and that's just continuing. The hyperscale community are driving a lot of the activity around where new zones are going to be, the services that we're using on a day-to-day basis, and also the ancillary platforms that use those as their fundamental architecture. Now, for us as an industry, obviously we're moving to address those needs, both from a physical infrastructure positioning from new buildings to support their growth, but also the network side that are driving that activity. We're seeing an enormous growth. Just if you think back to probably around 9-10 months ago, when we really started the whole work from home, when the lockdown started, certainly in North America and across Europe. Asia was a little bit ahead of that. we saw Microsoft having to add 12 million users for their Teams platform in 1 week. Now, I think we all experience the challenges therein, and similarly with the other platforms, there was it took a couple of weeks, but all of them just stepped up. They put new servers in place, new infrastructure in place, new data centers were built to accommodate those and expanded and extended. And we've seen an enormous growth in that. In fact, let me just move my, there we go, so I can see there. The hyperscalers themselves, you saw just tremendous growth. In fact, I'm not going to read these slides. You have these slides, both from enterprise and hyperscale. Just the amount of traffic that was driven to all of these platforms was through the roof. There we go. That also accelerated a new form of deployments of platforms. As new servers were being put into place there, obviously densification is becoming more and more commonplace. With the use of virtual machines is now an absolute standard. And we're seeing an absolute shift in the types of platforms that are being used. GPUs are fast replacing the normal 8086 architectures. Hesitate to use the word 8086, it probably dates me, but the traditional compute chipsets. There's FGPAs and GPUs that are just moving more and more into the server markets as major compute platforms. And as we see more machine learning and artificial intelligence, early artificial intelligence platforms coming to the fore, the transcoding at the edge that's required for a lot of the VR work that's going, even just all the unified communications that we're using is putting such a tremendous load on the server platforms that our clients in particular are looking to expand their footprints, and not only expand them, but actually make them denser and denser. And we're seeing that the traditional server platform network racks that have been placed out in the field for the last 10, 20 years, where they were designed to accommodate 7 to 10 kilowatts of power, are just not cutting the mustard anymore. We're really seeing the requirements for up to 50 kilowatts in either a full row of servers or just mixed capacity. And that's required a totally different way of thinking about dealing with that heat rejection. And so one of the things that we did at Align, designing a whole new type of cooling technology called the Delta Cube, which allows us to give that extra capacity to our clients. The way we've designed this and deployed this, basically that one cube is the equivalent of 146 kilowatts of heat. So an array of 4 feet high and 18 feet tall is the equivalent of 4 traditional cracks and cores at a tremendous decrease in power and total cost of ownership and water usage. So the drive to densify as servers are being placed in new and existing places, reducing the energy load that's required. Everything that we're doing is a speed to market play to keep the infrastructure in the data centers appropriate to the drive and the need that we're all putting on them on a daily basis. Also, the ability to deploy these things faster. We've switched to a modular technology. All of our infrastructure can be deployed within 2 days anywhere in the world. The just-in-time delivery, you can see here 2 20 megawatt deployments going into place here. And what we've done is move to an off-site manufacturing process, so that we reduce the carbon footprint on the manufacturing cycle of the site itself, reducing the waste, all of the materials that could leach into the water tables. Everything we do is based on speed to market, speed to delivery. And we're seeing the industry respond appropriately to all of the requirements to bring these to the fore. I've run through those pretty quickly, so I want to give time to Dan Davies to go through his slides here. So Dan, let me hand over to you directly. And Dan, I think you're muted.
Thanks, Phill. I appreciate the opportunity to participate today. I think what we're struggling with today is kind of how the network community has responded to, as you said, the new demands in the COVID or pandemic-driven environment. Just on kind of the perspective I bring, I bring to this conversation kind of the perspective from the long haul network side. I've been doing this for around 30 years. Certainly miss the opportunity to meet and spend some time with a lot of friends face to face, but it's a different reality we're in this year for PTC. And I'm continuing to do that today, is focusing on the long haul network side, the basic, kind of backbone connectivity across the United States. At Arcadian, we're continuing to build throughout the US, put new long haul fiber in the ground for our cloud content and carrier and cable customers. For us, we're building along roadways that have never been built along, and communities that have never been touched, tribal territories that have never been close to long haul fiber routes. And with our partners, we're basically, kind of directly connecting, our new communities that we're building through to the internet backbone. So I have the advantage of kind of looking at this either kind of literally, you could talk about this from the bottom up, from the core backbone, which is largely fiber in the ground, or kind of top of the ecosystem down. So my view is kind of from the view of the biggest users of fiber infrastructure globally. We have the amazing advantage of talking to each of them daily. And for them and for what we are doing, this shift to work from home that we've been in, kind of 9-10 months of this has really been tremendous. And that's what we're going to talk a little bit about today. When you think about what we've done with the shift to work from home, we've effectively moved millions of heavy enterprise IT use employees and moved their IT needs from well-served, central urban and robustly connected suburban office buildings. And we moved them almost literally overnight into their home offices, their kitchens, their new workspaces that are in very disparately located homes. And we have, expected that in the United States and throughout the world, that this massive shift of bandwidth, flows, storage, and compute, that somehow it will all just sort it out. And actually, amazingly, as Phill alluded to, with a lot of hard work amongst a lot of folks, some of whom I'm sure are viewers today, that here in the US, it happened fairly, on a fairly invisible basis. It happened in the background. The functionality continued. We have customers, clients, partners that are not US based, and it was not as seamless everywhere. Europe had a different experience and different continents had a different experience. From our perspective, that shift of taking, literally millions of heavy enterprise IT users and shifting them, to home gave everybody a firsthand experience of where some of the weaknesses in our fiber infrastructure are. And I think that there's some clues there as to what we may need to solve for as we look at layering on 5G, as Phill indicated, AR, VR, which are entirely different stresses on a network. Today we have, enterprise employees, and you probably encounter them as I do on a daily, weekly basis. We work with other folks, virtually. So we have folks in other enterprises working who can't make video calls from home because maybe their kids are downstairs learning or gaming at the same time. We're experiencing these, kind of limits now with the pandemic-driven changes before we even try to layer on top of our networks what 5G will bring, AR, VR, a move to, rather than platform gaming, to total underlying streaming gaming, all of which will add additional stresses. But COVID, and everybody's probably sitting at their home, watching this. COVID has personalized the limits of our broadband infrastructure across pretty much the entire worker population. The way we look at it, the way I look at it, this move to work from home has expanded the definition in the bounds of the rural-urban digital divide. You've probably heard that term, where kind of core urban areas have kind of great fiber infrastructure, and as you move out to the hinterlands, kind of less so as you get in rural America. What I think is really quite happened there is that the definition of rural and rural-urban divide, it's no longer the western slopes of Colorado. The rural is no longer the deserts of Arizona. In that rural-urban digital divide term, that new definition of the rural broadband problem extends from basically the third ring suburb of a major city all the way to the next third ring suburb, major city, and all the homes in between where all of us are trying to, kind of work and live, and our kids are trying to learn and game. And so it's really broadened that definition of where that divide is and personalized it. But let me give you a picture of what the long haul network really looks like at scale. We'll take a look at that. We'll take a look at how, give you a brief background on how it was built and what clues that may have as to what we need to do as we look forward from a long haul perspective. So here, what you see in front of you, the black lines on the map, were basically the long haul networks that were built in the 1990s by folks like myself and others to create Internet 1.0. And there's probably 6 or 7 long haul networks and probably about 12 regional networks here. These black lines are not exactly where the long haul fiber is. This is based on ping data from some great folks doing some great work in the University of Oregon. It's based on ping data, and they tried to provide a depiction based on what they could discern of where the long haul fiber routes are. And while these lines aren't perfectly accurate, they do tell the story of what happened when we were building long haul the first time. If you see 2 black lines that look like they're pretty close together, the reality is it's in the same trench, if not the same cable. It's just based on the ping data that they created this map with, that they look like they diverge. So actually the diversity problem of fiber routes between cities is actually worse than it might appear here. But what is this? What story does this tell you? So the history is that when we were building long haul fiber networks in the 90s, we were valued as companies, and there were 6 or 7 of us that built it. We were built on, route miles completed equaled dollars of valuation of your company. So the incentive was to build what's fast and cheap. As a result, we built the most expensive way, the fastest way we could. Hardest part of building a long haul network is getting rights of way. So when we all found an easy rights of way to build along, we built right along with each other, or we actually swapped fibers in each other's cable. That dynamic is what created this. And what is this? It's a long haul network that has actually a lot less diversity than even appears here. And more importantly, giant areas of the country that the long haul backbone doesn't go through. So essentially, this depicts the kind of rural broadband problem, but it's not kind of, as we said, not western slopes of Colorado. It's just basically outside every suburb. You've got giant areas of America where you have communities of hundreds to thousands to tens of thousands, a long ways from the backbone. Why is that important? Because to have affordable, scalable broadband in your home, in your business, you need to have cost-effective connectivity from where you are to the backbone, because the backbone is where you're trying to get to for the internet bandwidth. So it's really a problem of, community point on the map kind of here, long haul backbone hundreds of miles away. Because you only have a couple hundred, a few thousand people in a community, it's never going to make sense to build fiber from every individual community back to the backbone. But that's been the method that, as a government policy, that's how we've been trying to solve this problem, is building from community to existing backbones. Back up for a second. What's the real problem here? It's a problem of distance and dollars. Community, a point on the map, and a backbone hundreds of miles away. You need to close the gap. By definition, you can't move the community. So what's the obvious answer? Move the backbone, which is what Arcadian is doing. So every time we bisect one of these giant areas of the country, you bring the backbone, you have the distance to, on average, the communities in these unserved, underserved kind of technology deserts. So that's what that's, from my perspective, our perspective, the cause of the rural broadband problem. Historically, that's why it's happened, and that's how we're helping to solve the problem. So let's click forward once more. So on top of that long haul backbone, here's what the internet became. Is, in my mind, the internet, having been at this so long, is fairly simple. It's giant data centers sprinkled throughout the planet, connected by fiber that goes across continents and under oceans. And eventually that connection gets to your eyes and ears wherever you are, right? That's the basic, when you're at infrastructure level, that's what it is. couple things I'll point out on the map here. You see some company logos here. These are their publicly announced major data center sites. What do you notice? For those of you who kind of understand it, you'll understand why they are where they are. They're at convergence points of long haul fiber, right? Why is that? Well, if you're going to put $200 million to $1 billion into a data center, you want to make sure it's a performing asset. It's doing its thing. It's meeting compute and storage needs of its customers and its owners. I would say the relationship between a data center and a fiber network is kind of the relationship between a car factory and electricity. Electricity goes out to the car factory, production stops. Very bad thing. Same thing with a data center. So when you have multi-$100-million data centers, they're putting them where there's at least 3 or 4 long haul fiber networks, because when one get cut, and they get cut all the time, that it stays connected and stays in production. So when you look at what we're doing, when we're adding new long haul routes, we're adding new convergence points where the data centers can go. So if you look at the green line on the map, which is our one of our first projects, and the blue line is the one that may probably follow right after the blue, right after the green. If you look at kind of where they intersect, the green line has a new 3-way intersection. The blue and green have 2 4-way new intersections, places where new data centers can grow. So that kind of, when you put new long haul lines in the map, it really does add a lot to the ecosystem. Our customers buy our fiber because they're connecting, multi-$100 to billion-dollar data centers to one another in the 3rd, 4th, or 5th way, so that they always stay connected. That's what that set of customers is interested in. Our other set of customers is the telcos and cablecos and communities along the route that you now brought, as we pointed out, brought the backbone closer to those communities. Now it makes sense to make investment in those communities of fiber to the home, fiber to the node. You gotta think about this. If you're in like a Durango, Colorado, you could do fiber to the home in every single home. It's a wonderful community. We spent some time there. But that bandwidth hits the kind of city limits of Durango, Colorado, which is in southwestern Colorado, kind of where our green lines goes through. And then you're hundreds of miles from the backbone, the bandwidth can't get out. So what's the rational economic decision? Don't invest in the fiber in those local communities, because there's no way to get it out of the communities, right? And so that's our function in the ecosystem, meet our cloud and content companies' needs for data center connection, meet our cableco telco customers' needs for backhaul, to allow them to grow bandwidth and services, in their lesser connected markets. So we do solve a really hard problem. You can call it the middle mile problem, the backhaul problem, but we don't solve the whole problem. We need partners in the ecosystem. Our customers, some of you are on the call, some that are not going to be customers, to build off of our backbone and meet that new pandemic-driven, kind of enterprise in the home need. And so we've got some speakers here later in the session here. I'll turn it back over to Phill.
Yeah, that was great.
Folks in the ecosystem who can meet that other need.
Right. Yeah, thank you, Dan. That was really interesting. Then Ben, why don't you take us down another layer in this conversation?
Yeah, absolutely. Thank you, Phill. Thanks for the opportunity. Great setup, Dan. The reality of missing components of backbone and major parts is critical, and I think the pandemic just shines a great light. My perspective's a little different. I've been operating in this space for the last 25 years, and one of the things that's core, to my perspective is I believe location matters. Ultimately, when you're talking about a very complex ecosystem, if you don't have the perspective around location to understand the problem in the connected world, you miss the key ingredient for understanding unit economics, i.e. building a community all the way to a backbone that's really far away. You miss the understanding of demand and the potential of demand, and you miss the competitive context of very capital intensive industry. And coming at this conversation from not just one perspective, but looking at it from an ecosystem perspective, there's massive revenue opportunities that are available across the ecosystem that have never been greater for our community. And I'll just peel the onion on that thought process a little and dive into it. you know, connected to fiber, the company I lead has the privilege of, you know, running a platform that today houses over 660 million locations being managed across, you know, a wide spectrum of the ecosystem, you know, carriers, broadband providers, managed service providers, hyperscalers, all kinds of different perspectives contribute to that platform. And what we see is, you know, 3 layers of an ecosystem being actively invested in and transformed digitally. You know, infrastructure is manifesting itself deeper and deeper into the edge. Fiber needs to be penetrated further to support the potential of 5G, as well as, you know, the access that people are gravitating when the economics allow for it, first and foremost. That fiber needs to connect to something, and that something is increasingly across all aspects of our life. How we work with applications like Salesforce, or compute held in Microsoft, AWS, or Google. How we learn in terms of you know, education at school, getting access to not just Zoom conferences like we're on now, but tools from Google Classroom to Schoology, and how we entertain ourselves in a world that you know, connectivity plays a key role as the supply chain. You know, if you're not subscribed to tools like Netflix or HBO Max or other subscription services, you know, you surely will be shortly. It's just a reality, and those data centers are being pushed closer and closer to the users, because that consumption across the cloud for entertainment, for work, for data, for compute, you know, needs to be positioned closer to the user, consume at the level that, you know, they want to. We are increasingly in a mobile world, a world where, you know, the economics of fiber don't always work out. The capital intensive nature of the business makes sense that mobility is a part of the infrastructure layer, and we're seeing macro towers move to, you know, attachments to utility poles, small cells, rooftops, new in-building wireless systems with antennas and spectrums being used in all kinds of different ways. And there's a fantastic opportunity in this infrastructure layer over the next 5 years, because the world as we know it is moving to a digital economy. To Phil's earlier point, you know, that is the new norm. How we work, how we live, how we play, how we govern, it is increasingly a digital world, and the infrastructure collectively is not there yet. You know, 1.0 to 2.0 to 3.0, we're going to see this evolution, and we see it being played out in terms of capital deployments, new builds, broadband players being introduced from the electric utility industry to new MDU you know, focused operators. But infrastructure deployment across the board on all these layers is being pushed closer and closer to the user. Another aspect of the ecosystem that's being manifested in new ways is that services layer. You know, when you have this massive infrastructure build out, and you have users that are distributed by nature, and COVID's just you know, exacerbated the opportunity of work from home, plus offices, plus retail, plus government, plus schools, you know, and all of them are physically not going to pack up and move into the data center with the cloud. You know, you have a disconnect between users and what they're trying to consume, you know, meaning that network is needed. And what we're seeing is there's a change of architecture. It's not just more, it's fundamentally inserting peering fabrics at a local level. It is, you know, moving content closer to the edge. It is orchestrating a multi-cloud world where one application is not winning everything. It is really the 8,000 SaaS application, the multiple different cloud platforms, the multiple different subscriptions, and that is complex. And the services, the peering, the architecture to support that is creating its own fabric and knowledge base and ecosystem that is of tremendous value and opportunity right now. And then the last, layer of the ecosystem is more about the user. The acquisition, the connection, the value creation, how to simplify this complex world, how to create a user experience where the norm in the market today is, I want it right now, and I want it faster, and I want it better. And oh, by the way, make it cheaper. And that norm is not going to change. That is the reality that this entire market is grappling with. But it is one compounded with massive demand and massive increasing opportunity and frankly business opportunities that haven't been invented yet that will be created. Speed, to Phil's point, is not just in terms of the bandwidth that people are consuming. It's the execution capability of the value creation that they're trying to get done in the first place. And it is increasingly moving away from just traditional users in offices and homes. And what we see, what we think we see over the next 3 to 5 years is this concept of intent becoming very important. The concept of machines and devices as being just important users in the community of digital transformation and execution as the users themselves. So a car that's driving down the road by itself can know when to stop, can know when to turn, can know when it is compliant with the regulatory environment that it's driving through, or a new enterprise takes an application online and has a massive data upload or download to create the initial event. The network adapts. The network creates the opportunity to deliver those services. As we step forward to the next slide, Phill, we start to pull back the covers of a new entrant into the equation, which is 5G. And if we want to call it a new thing, that's great, because it shines light on a major capital investment that frankly affects all three of those layers of the ecosystem. But it is more about what is the potential, and not just looking at it in terms of traditional infrastructure and bandwidth, because in my mind that's not the economic opportunity. The economic opportunity for this ecosystem is to leverage what 5G and what fiber and what data centers at the edge and content and the edge and changing peering fabrics create. And it's the outcome-based business opportunity, enabling omni-channel retail to create a better experience and actually help drive sales up and profitability up for the retailer in the new world, to change the landscape of energy efficiency with smart buildings and smart cities, and have the analytics and enablement and the coverage across all of it to do that, to enable autonomous cars that put that many cameras on a car, the sophistication of the data and software stack, and talk about the regulatory environment, comparing it to flying an airplane, is a massive data problem that exists just to get those cars on the road in any meaningful period. That's going to take fiber, that's going to take data centers, that's going to take changes in peering fabric, antennas, spectrum, the whole ecosystem working together to enable that reality. And combine that with, on-demand everything. When we look at it, while Netflix sort of set the tone on entertainment and the subscription economy, by no means is that over. And when you think about what 5G, the fiber infrastructure, the antennas, the change in ecosystem, the bandwidth enabled in a mobility environment, what that means for gaming, what that means for smart cities, transportation, retail, it really has profound implications for how this industry is going to impact every aspect of our life. And oh, by the way, people still want raw bandwidth. They want that connectivity to exchange, which is a meaningful opportunity with new ways of doing that. Last but not least, just how we're attacking this in the next slide, Phill. From my company's perspective, connected to fiber, our role in the world is to digitize this world. If you don't have a system of intelligence and record, you can't drive automation. You can't get the perspectives around location to understand what levers to pull. You can't transact, and ultimately, that's what the market needs to. If you want to satisfy the demand of I want it now, just as Phill and his team have created that just-in-time manufacturing to build massive data centers. We're doing that with the digital world and enabling people to get closer to hit the blue button and get your answer immediately, all the way from plan to prospect to price in the connected world. I'll hand it back to you, Phill. Appreciate the chance to share.
Thanks, Ben. That was really, really interesting. Thank you. So Jeff from Calix, why don't you take us down another layer and talking about the broadband aspects.
Thanks, Phill. Yeah, hi, I'm Jeff Brown, everybody. Historically, my involvement in PTC has been on the service provider side with the DCIs, the data center interconnects, providing 100 gig DWDM type long haul circuits and managed wavelengths to the hyperscale providers and other service providers. About 3 years ago, I went to work for Calix, who from the service provider perspective, you'd call a vendor. You might be wondering, why would I do that? I'll tell you in a second. I work with network operators around the world to help them plan and design and implement their optimal broadband access network, and then create innovative services on top of those platforms, and then help develop go-to-market strategies to help them win in their marketplace. You've heard the other speakers talk about the growth in overall data traffic. It's already growing significantly prior to COVID. Most estimates for compound growth rate globally, 20 to 25%, obviously some more westernized countries. 22% or so is a reliable conservative figure. And that number totally exploded during the pandemic. And as Phill said, it somewhat accelerated by maybe up to 10 years, the bandwidth needs that the overall community needs. So while the core of the network has seen tremendous innovation and upgrades, as Dan mentioned, the middle mile and the last mile access networks remain the bottleneck. So delivering high-speed broadband to all the consumers, the small businesses, all those premises is the long pole in accelerating society's digital transformation. We can go to the next slide. So as a result of all that need, there's a tremendous, enormous influx of capital investment in broadband as investors capitalize on these tailwinds. In addition to private funding, there are some countries like the United States, for example, and others in Europe, and in South Africa, for example, where there's been a significant degree of government-driven funding to broaden broadband deployment in underserved and non-served areas. So a lot of capital coming in for a variety of different operators. The competition for broadband is coming from a lot of different directions, leveraging multiple technologies. You can see on the left there, Amazon and Starlink are each investing $10 billion each to deploy satellite broadband, thousands of satellites, joining OneWeb, who just came out of bankruptcy, in the mix, and existing providers like Viasat. So these are all from the space side, satellite, low Earth, LEO type providers. On the upper right, you could see in the US specifically, $4.6 billion was invested in a recent auction to leverage the 3.5 gig mid-band CBRS spectrum, where the auction participants included utilities, wireless operators, telcos, and cable operators. That's all last mile up to 1 gig spectrum. Mobile network operators are leveraging their existing LTE networks to offer home broadband service across hundreds of markets. In the US is a good example. You've got T-Mobile and Verizon. And in Verizon's case, they're also going to leverage their 5G build out to offer even greater speeds. Those current speeds they offer are 25 meg and 50 meg respectively for Verizon and T-Mobile. So despite all of those investments and all that, what may seem to be daunting competition from a number of different people coming in to provide broadband, the reality is that those technologies can't scale to meet the bandwidth needs that we're talking about. If you look at that compound growth rate over the next 10 years, not even counting the fact it's been moved forward, but there's simply those technologies for the most part cap out at around a gig and aren't enough to be able to provide the needs for communities moving forward. So the reality is that fiber operators with long haul, middle mile, and access infrastructure are really best positioned to capitalize on these opportunities. You know, the service operators that traditionally attend PTC, you're the best positioned to monetize all the growth potential in broadband. And in the process, by deploying fiber, create barriers to success for those other competitors who are leveraging those technologies that are less optimal than fiber. So I work with a lot of operators who just a few years ago were focused on, say, optimizing their legacy brownfield networks, right? Optimizing copper, squeezing more bandwidth out, you know, looking at technologies like vectoring and bonding, despite the fact that operational expenses for copper networks are universally considered to be twice the OpEx for maintaining a fiber network. And it gives you asymmetric bandwidths that aren't really going to keep up with your primary competitor in the market. Or on the other side, I worked with cable operators who had antiquated coax network, and they're trying to keep up with the DOCSIS upgrade initiatives, and they spend all of their cycles turning down their network and replacing their nodes or taps or modems to move from, you know, up to 3.1 or waiting for 4.0 commercial availability for DOCSIS 4.0. So more recently, you know, especially because of the pandemic over the last year, those operators have gone ahead and pulled the trigger and made the move to invest in fiber, harvesting all the benefits you get from the best future-proof technology with, you know, infinite amount of bandwidth. So some of those are brownfield networks they're upgrading to fiber. Some are greenfield new networks. Some are coming from sort of outside the industry, so like utilities deciding to get into broadband networking. And some are intended to be open access infrastructure networks. We work with companies, especially in areas like the UK, Australia, New Zealand, and South Africa, where open access networks, layer 2 networks, are quite popular. So even traditional wireless internet operators, or WISPs, understand that fiber networks bring significantly higher valuations, and they're looking to incorporate fiber to the prem in their networks, and over time utilize fixed wireless for more what I would call niche kind of corner cases. So what I hear, you know, from some operators is a resistance and argument along the lines of, yes, the fiber absolutely makes sense. It's the best technology. And where I have high ARPU customers like enterprises, small cell or microcell backhaul data centers to connect to, it makes a lot of sense. But it really makes sense to build out fiber everywhere in my markets. All right, so let's talk about that for a second. Next slide, please, Phil. So the biggest takeaway for me from the pandemic are the behavioral changes in how people work and live and learn, right? There's been a steady shift over the last decade to cloud computing. In many countries, there's a concerted effort to build out 5G networks. What really at the very, you know, if this is a baseball analogy, in the first inning, right, of that 9-inning game, you've got the Internet of Things, explosion of connected devices continuing, artificial intelligence, some of the applications that were mentioned by the other speakers, a lot of the next gen apps like that need high-speed broadband and low latency are emerging. And all of those trends are fundamentally accelerating and changing how households use data services. So it's not just an emergence, but it's actually an acceleration and a permanence to at-home behavioral changes. You can look at the graph there and a few examples: telemedicine, aging in place, which is not on there, cloud gaming. These are just a few examples of emerging applications that network operators can leverage to grow your consumer broadband ARPU. A lot of sophisticated operators are leveraging cloud-based platforms that interoperate with your fiber infrastructure that give operators analytics and deep insights, enabling them to customize their marketing approach, tailor the service packages to give the customer the right kind of service that they need with the best customer experience possible. Again, kind of dovetailing on some of the critical needs of data in this new digital environment that Ben talked about. So the pandemic has accelerated the shift in virtual work and education that was already happening right before COVID. Work from home and e-learning will subside to some degree post-pandemic, but other economic factors in play, like the cost of commercial real estate, soaring university tuitions, et cetera, are going to ensure that work from home and e-learning aren't going away at all. Another key trend that any network operator understands is around over-the-top video, right? Network planners have been right-sizing their access network for some time to plan for this ongoing shift in video content that, you know, before would come over some other pipe, right? Some other physical medium coming into the house, and now coming over the broadband connection. So that concept of cord cutting, as it's called, right, is on a continued increase and will absolutely continue for the next several years. There's also a synergy between what's happening in the mobile network and the fixed broadband network, right? So some of you on this call may operate both types of networks. Building out the next gen mobile network with all the small cell densification required has a number of, you know, logistical, economical, operational challenges. Mobile operators are relying a lot on Wi-Fi offload to move the traffic off the mobile network to the home broadband network. So operators that have a fixed and a mobile business, you know, should look beyond just the specific segment EBITDA contributions, which, you know, today for the most part around the world tend to be more favorable to the wireless part of the business. Is more faster growing, right? Somewhat higher margin, but they need to take a look at an overall contribution in terms of understanding how the fiber-based fixed broadband access network helps reduce the overall OpEx on the mobile network side by offloading that traffic to Wi-Fi, thus reducing the need to so quickly need to upgrade all of the backbone on the wireless side. That only works in scale though if you build fiber, you know, to the home, right? Do a strong FTTH, FTTP type of build out, because only a small percentage of traffic is offloaded at community Wi-Fi hotspots. So operators are clearly looking at ways to kind of densify and build out fiber on a broader basis. So when you think about the consumer household, the number of connected devices, the variety of applications, you realize that from a networking perspective, the consumer household has become the new enterprise, right? From a telecom perspective, it requires high-speed symmetrical bandwidth. It requires application prioritization, low latency, and in some cases, you might even have to deliver SLAs, network statistic reporting, et cetera, just like you would in the business-to-business environment. Because of all of that, operators are now viewing the aggregate residential market as integral to a fiber deployment, nicely complementing the customer segments that you already serve, including SMB, enterprise, and wholesale. That's all I've got, Phil. Thanks.
That's good. I do like that phrase, home is the new enterprise, and that's so true. And becoming more so in the last several months. So we've talked about the data centers, the proliferation of these large buildings that house the services. We've talked about how the internet started to grow and that long haul bandwidth across the Americas, the emergence of 5G, and then Jeff talking about particularly these services that are coming to the home. So let me finish off with bringing in Doug from Kentik to talk about some of the operational requirements and the way the traffic flow is changing. So Doug, let me hand over to you.
All right, thanks, Phil. Yeah, my name is Doug Madory. I'm the Director of Internet Analysis for Kentik. I always wanted to go to a PTC, so this is my first one. I minus the trip to Hawaii. I'm in Hawaii in my heart. I'll have you know. So in this segment, we entitled "The New Normals of Network Operations in the Year Ahead," and so this is based on a conversation between myself and Avi Freeman, our CEO and founder, talking to our customers about what they're looking at going forward in the next year. If you want to go to the next slide. Just a quick word, who are we? Kentik, if you don't know, is the network observability company. So we are known for our net flow analysis and analytics. But in the last year, we've expanded our offerings into BGP monitoring, performance latency monitoring, and we have over 300 customers, including tier 1 telecoms, providing us very large volumes of flow. So we have a very good perspective on what goes on the internet. And that's my job as a computer scientist in the company. Next slide. So let's get into some of these new normals. So the first one is the expanded disaster recovery planning. So not many, if any, disaster recovery plans included a scenario the magnitude of what we're dealing with now. Scenarios we would plan for would either be maybe long-lasting, short-lived, some defined geographic impact, but unlike an earthquake or a hurricane, this pandemic's a truly global event, and as we're well aware by now, this is of indefinite duration, thus making it uniquely difficult to prepare for. So what some of the customers, some of our customers, certainly in the initial months of the pandemic, I'm sure some of the panelists would concur, supply chain became a big problem. Not just knowing where to get equipment, but understanding some of the downstream dependencies of equipment, where maybe a hard drive comes from one place, a motherboard somewhere else, a fan from yet another country. As countries were opening and closing in the initial months of the pandemic, this complicated equipment acquisition. And so the lesson learned out of that one was, having a better understanding for critical equipment, understanding any downstream dependencies for stockpiling, such equipment. The other thing that was threw us for a loop, threw our customers for a loop, was losing physical access to data centers that are geographically separated. So, a lot of DR scenarios assume this is, again, a defined geographic impact. But we had customers losing physical access to data centers in disparate locations, complicating their ability to continue to operate. The next new normal is around zero trust. So zero trust is if you don't know, a security model that tries to move away from the traditional security perimeter model to a corporate compute environment that is segmented into secure zones. And by isolating these resources and services, the hope is that you could better protect these services individually by limiting the impact of a security failure. This takes on new meaning in our current work from home environment, where in many instances, almost the entire workforce is working from home, connecting through untrusted networks there is no trusted network anymore, because we're all connecting through untrusted networks. So we're all living this zero trust model by necessity. If you advance to the next slide, thanks. So advanced provisioning. This was something that really, this was a lifesaver, as everyone here is aware of, as traffic ramped up in March 2020. We had global networks able to handle the additional load due to advanced provisioning. This intentional slack built into the system to allow for future capacity. And it was this, this is what kept us online. And what we're seeing with our customers is a continued work on trying to now catch up and rebuild that advanced provisioning to allow for future growth. The graphic I included in this slide was our analysis of volumes of video traffic based on it. We have a OTT, a service tracking system that combines NetFlow with a DNS tap, so we can track how traffic is getting by volume, by a few different metrics. But you may recognize the slope here as we have an explosion of video conferencing traffic in the spring. It subsides to some extent in the summer as people start to, schools are out, people in some places start to relax, and then it comes back in the fall as schools go back in session. And as things continue to degrade in the last few months, we've seen this still increasing yet more, the video conferencing. That is a perspective from our end. If you go to the last slide. So the last two new normals, not all of our new normals are pandemic related. One of the next one, number 4, is about edge and cloud native deployment. And in 2021, we expect no app gets approved that isn't cloud native, potentially containerized. We expect to see more, the first of these edgier deployments taking place around gaming, manufacturing, logistics, distributed performance monitoring. This trend will continue, and the final new normal is around the regulatory environment, our favorite. We're currently living in the world of GDPR, CCPA, which is the California Consumer Privacy Act. These are here, the reality today, but what's the landscape going to look like tomorrow? These days, the Section 230 of the Communications Decency Act has become a focus of political debate. The law protects internet businesses from liability if a user posts something illegal. But as our social media platforms become central to our politics, this protection may erode or may be reinterpreted in some way. And so we have, in the space that we operate in, we have a lot of customers that are concerned about what kind of changes may be required for policing content in this this new normal. Specifically, companies may need to form a more developed opinion with their stance on the law. People thus far just try to avoid wading into this debate. But we have over 20 customers in the cloud and CDN space specifically that are actively trying to wrestle with this. More meetings for the legal team. So let me wrap that up there. Just 5 new normals that we're seeing in the next year, and based on these challenging times. All right, back to you, Phill.
All right, thank you, Doug. So let me stop sharing my screen and hand that back over. Do we have any questions that have come through? Let me just have a quick look here. So there's a few in the chat. So Grace, are you able to, let's see, no, they're just questions. So Grace, do we have any questions for the group? We've just got about 2 minutes left. No? Well, that was a fascinating conversation. So I want to thank you gents for taking the time out. And I do hope that, Doug, we get to meet in person next year at somewhere around the pools. In the Hawaiian village.
That'd be great.
So I think we can give everyone 2 minutes back to their days. So gentlemen, unless there's any last minute thoughts that any of you would like to share.
Thank you very much for the opportunity, Phill, and PTC for being gracious hosts once again.
Yes, indeed. Yes, indeed. All right. Well, that's it from this session then. So thank you. I would normally say meet you around the bars, and but we'll have to do that virtually from here on in. But thanks again, and see you all again soon. Take care.
Mahalo to our panelists. Last chance to get on the leaderboard or get to the top of the leaderboard and win. Go play and have fun.